Trying this new tapping fluid. Very thick stuff. It seems to work really well. Of course, I'm just tapping into cast, which is really easy to tap into. But now I need to take this back off and put a bend in it. Hello, and thanks for joining me. Well, let's put flood coolant on this mill. It's kind of a hard decision for me to make, but I think it's probably the best method of coolant on a mill. There is mist. I have used it before. It works good. I think the flood coolant does better about moving chips out of the way. Seems like if you have to have enough mist to keep the chips out of the way, you got it all over your room or in the air and you're breathing it. And I really don't like doing that. But I bought a coolant tank made by Vortex. I think it's going to be a good one. To be honest with you, I'm not super impressed with some of the quality on it. And I don't like the way it's laid out. But I think it's going to work good, and with some modification, I think it'll be convenient to use and easy to clean out. As far as coolant fluids, a company named Master Fluid Solutions sent me some samples and sent me a gallon of mist coolant, which I may end up going back to, I don't know. And they sent me 2 gallons of their Trim Microsol 685 coolant. And it's supposed to be really good for corrosion control, variety of milling applications, different metals. And it's fairly economical. It's at the highest concentration, it's 10 to 1. They also sent me some tap heavy, high lubricity, it's hard to say, tapping fluid. I've used it one time. It's like honey, stays on the tap. Probably comparable to some other stuff, but so far I'm impressed. Thanks for sending that to me. Let me review some of the changes I'm going to make on here. Okay, first thing I'm going to do is make a couple of tabs that bolt on right there. And then I'm going to attach a angle iron framework to hold this tank back here. I've got the angle iron basically cut to size. I'm going to mill it to fit inside each other and make a framework right there. And this angle iron will weld to my tabs that bolt onto the back of the mill. The cord on this thing leaves something to be desired. In reality, it's a good setup, but it's inconvenient. It's a magnetic switch. It's a little 1/8 horsepower motor on the pump. And this thing mounts on the wall or on the mill or wherever you want to mount it. And then you got a plug to plug into an outlet. Well, if I want to take my tank, lift it off and go outside and dump it out and clean it, then I got to haul all this with me. So what I'm going to do, and this will be mounted somewhere, so you got to take the pump out to get the tank out and clean it out. So I'm going to cut that cord off, and I'm going to mount a post on the side and a box. And I'm going to put one of those plug outlet switches in here. A plug and a switch. So there'll be a switch to turn on and a plug. I'll hook a plug onto the end of that, plug it in, and you just turn it on right there. Power cord will come out from that and into the outlet. But by doing that, I can just unplug this, lift the whole unit out, and clean it out. One of the biggest drawbacks to flood coolant, in my opinion, from what I've seen anyway, I've never personally had it on a mill. I've been around mills with it. it's bacteria growth in the tank and having to clean it out and end up with water on the floor because the pump plugs up. Anyway, I want to make it easy to clean. So that's what we're going to do next. We're going to drill these tabs right here and get started fabricating the framework. I really like this drill press. Nice slow speeds. Perfect. I think my metal's too dirty. Paint is fuming up and causing welding problems. I believe that's going to work good. I've got some bigger hose than this. That'll go through there and stop that thing from popping out of there and flooding my floor. Okay, here's why I went to all the trouble to do this. It came with a really nice magnetic switch. I think it's magnetic. Anyway, nice switch, wall mount. And it had the power to this coming from the bottom and a cord coming out of the top. And I put that on the wall or mount it on the side of the machine and had a cord coming from it. And there was no way to disconnect this wire easily. So, besides a lot of wires I don't like, but this here, you unplug it, quick release there, hope that holds up good. The drain goes into a little bracket there, and the whole thing can be taken outside, cleaned out, rinsed out, put back in. I may have to come up with a different quick connector. I do know these are not corrosion free. Hopefully the coolant has enough rust inhibitors to where it won't be a problem. And then put the drain in and you're ready to go. I was going to put a wire tie on the drain, but it's a snug enough fit to where it just sits in the filter just fine. So we're ready to fill it up with coolant and try it. However, my mill vise and table need some modifications to drain the coolant right. I'll show you what I mean. Okay, when I bought this vise, I was going to use either mist coolant or no coolant and carbide tooling. Well, I've since changed my mind and I want to try flood coolant. And I may go back to the mist coolant, I don't know, or no coolant. But this vise is not ideal for flood coolant. If I had known I was going to, for sure I was going to use flood coolant, I would have bought one with a coolant trough around it. So I've got to figure out a way to keep coolant on the table. And I've got an idea. It's going to sound drastic, but so here's what I'm going to do. Right there and right there, I'm going to cut a slot, a shallow slot on the back of the, or mill slot on the bottom of the vise. And I'm going to put a piece of probably weather stripping under it, something that will compress. And I'm going to put a piece of aluminum under it and bend it up and back to where it'll stop coolant from going off the side and to keep it on the table. And I'm going to do the same thing here, although I won't have a big piece sticking up. Back here, I'm thinking, you know, maybe that high will help stop chips and stuff from getting on my ways and back. I'll probably put a cover back there eventually. But anyway, it'll help keep it contained on the table. So that's what we're going to do now. We're going to mill the bottom of the vise. Okay, this may be a bad idea, and it may work great. I don't know. Well, I think that's going to work. I'll probably end up getting a different vise. Let's put this thing, fill this reservoir with coolant and try some milling. Okay, let's mix this stuff up. Supposed to mix 10 ounces per gallon. A 1 to 10 ratio, so that's going to be, I got 2 gallons here, that's going to be 24 ounces. This is not an ideal container for mixing, but looks good. Well, I've got kind of a dilemma here. It's not a big dilemma. I've got a reservoir over here without a drain. And it will fill up and then go across the T-slots to the other side where there is a drain. I was just wondering, maybe some of my viewers know how to prevent the coolant from getting in this side. I'm thinking about some kind of plugs in here, T-slot plugs. Anybody else ever do that? Okay, let's mill something that's hard to contain. This is not a groove. Let's see if we can keep the coolant on the table. There's a real test here. It's going all over my vise. Oh, look at there. Kind of makes sense. It's filling up on that side first. But it'll eventually get to the other side. It may be that I need to be going faster, RPM. No leaks. That's outstanding. Looks like I'm getting really close to leaking right there and right there. And nothing's run off the side of the table. And one of my main objectives is there's no chips on the floor. Last time I milled, there was chips 6 feet out. everything stayed on the vise or on the table. Well, that about wraps it up for today. I think I'm going to like this flood coolant. We'll see long term how it works out, but so far I really like it. I'd like to thank Master Fluid Solutions for sending me the coolant trim Microsol 685. Seems to be working good so far. Long term we'll see. Seems fairly economical. And I would like to thank Bever for the motor and the motor on the mill. It's working really well. And the casters. The self-leveling casters are amazing. Real good value. They're rated at 1,100 pounds, I think, each. So they can hold quite a bit of weight. So far they've worked out good. I think they're like 4 for 50 bucks. Maybe a little bit more. But you can't beat that. Anyway. Thanks for joining me. Be sure and subscribe and ring that bell.